Now, let's compare the traditional way of building data pipelines with the cloud-native approach. Before cloud-native, most companies built pipelines on top of fixed infrastructure. They would buy servers, install them in a data center, install tools on top, and then try to predict peak load and provision enough capacity in advance. On paper, this sounds fine. In reality, it created several problems. First, it was expensive. You had to provision for your peak traffic like Black Friday or a big product launch, even though that peak might only last a few days a year. For the remaining days, those servers sat mostly idle, but the company still paid for them 24/7. Second, it was slow to change. If you suddenly needed more capacity, you might wait weeks for new servers to be ordered, racked, and configured. Third, it was risky. If your predictions were wrong and a bigger than expected spike arrived, the pipeline could fall over just when you needed it most. Now compare that to a cloud-native pipeline. In the cloud-native model, we don't think in terms of fixed machines. We think in terms of code and events. We write small pieces of code, deploy them in minutes, let them auto-scale based on real demand, and only pay for the exact amount of compute time we actually use. For example, during an incident, your pipeline can scale up to process millions of events per minute. At 3 a.m., when traffic is minimal, it can scale all the way down sometimes to almost zero cost. This is why cloud-native pipelines are such a good match for AIOps. They can keep up with the chaos of production instead of forcing you to predict the future with hardware purchases. To understand how cloud-native pipelines actually achieve this behavior, we'll look at three core principles, starting with ephemeral compute.